All right, before we go over some examples finding end behavior, I want to explain why end behavior, this chart is the way it is. So even degree, if you remember the graph of y equals x squared, this is a parabola or the U-shaped graph. Notice that both the arrows are going up and our leading coefficients, it's the number in front of the term with the highest exponent, is positive. So both arrows are going up, that's why we have up, up. Now if I switch that to y equals negative x squared, that will flip your graph upside down over the x-axis. That's what happens. So it makes all the values negative, so that's why it goes down. You could do that with any graph with an exponent that's even. So odd is like the cubic graph, x cubed. X cubed, if you remember what that looks like, is this specific graph, which if you make that negative, just flips it. So notice when you had a positive x cubed, the arrow first went down, then up, and then when it's negative, it just switches the arrow, so it goes up, then down. One way I always remember this is if you choose the right arrow, you'll notice it matches the sign of your leading coefficient. So positive, both of them will go up. Okay. So that's just a brief explanation. So I might give you a problem like this, determine the end behavior based on this polynomial. Now, first thing you need to do is find the term or terms that have the highest exponent. So we have this term right here has the highest exponent. If there are more than one term, so if there were two of these, you would need to combine like terms before we continue. But there's just one. So this is the only term we care about. So I'm going to look at the leading coefficient. My leading coefficient is positive 5. So it's positive. That means it's going to be this section right here. It's either going to be up, up, or down, up. But our degree is 15 because it's the exponent of that term with the highest exponent. Okay, well 15 is odd, so that's this section right here. I have to close that off. So that tells us our end behavior will be down and then up for this graph. Now this only works if as long as it's not in factored form. In factored form, we have to do it a little differently, and we'll talk about that in a future unit. So same idea with this problem. We're looking for the term that has the highest exponent. Actually, nope, that's not the one I wanted. Oh, this is the finding a y-intercept. I messed up. Here we go. It's right here that I was looking for. I still want to do end behavior. Sorry about that little goof. So right here, we're looking for the term with the highest exponent. That's this term right here. Just so happens both of them are at the end. So our leading coefficient is negative 10. And our degree is positive 4, which is even. So if I go back to that same chart, we had a leading coefficient that was negative, so that's down here, but then a degree that was even, so that's right here. So our end behavior would be down, down. And that's how you do end behavior.